my dear mechanical engineers. How are you all? कैसे हैं सब लोग? What's up? Please guys do join me fast because we are going to have this wonderful session for mechanical engineers for those who are going to appear in BARC 2023 examination. Myself Chandrasekhar, welcome you all to this India's largest, the best and your favorite live learning platform, that is BYJU'S exam prep. So please guys do join me fast, and those who are already here please respond through the comment section so that we can start the session. आज के session में I will be having around 12 questions from the various important topics of fluid mechanics, and there will be around 8 questions from the heat transfer. As the fluid mechanics is a lengthy subject compared to the heat transfer, so there are 20 hand-picked questions from which you will be able to understand or revise the fundamentals, revise the concept. So that will help you to improve your performance in this upcoming BARC exam. All right. Hi Roshan. Good evening. Namaskar. Adab. Shubh Sandhya. Good evening. Sat Sri Akal. Assalamu alaikum. So I hope everyone is safe and sound. So please do let me know if my audio and visual quality are fine or not, so that we can start the session. मेरी आवाज आ रही है सब लोगों को? Am I audible and visible to all of you? All well? All right. Please respond through the comment section, all of you. So for those who are meeting me for the very first time, जो पहली बार मुझसे रूबरू हो रहे हैं, this is my quick introduction. I am having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have cleared engineering services examination also in the year 2009, as well as I am mechanical engineering graduate from IIT Delhi, worked in Steel Authority of India Limited also. Hi Mithun, welcome. Good evening. Welcome guys. So keep your pen, notebook and calculator, because the more you practice on your own, the more confidence, the more motivation you develop to crack this BARC examination. All right. And if you have any doubt, anything to discuss, one-to-one, you can connect with me through the mail ID which is there on the top of the screen, and I would strongly recommend you guys to be part of my Telegram group. That is Mechanical by Chandrasekhar. Hi Kiran, welcome. The link is there on the bottom of the screen. Shall we start? So this will help you to revise your fundamentals, the important fundamentals, important concepts of various topics of fluid mechanics and heat transfer. And before we proceed further, there is an important announcement. Tomorrow at 7:30 p.m. Dheeraj sir and Ashutosh sir will be taking a special workshop for GATE 2024 aspirants. How you can have efficient preparation journey for GATE 2024 examination. So it is going to be very, very helpful, because मेहनत हर कोई कर रहा है, but to convert this hard work into success needs the special attention or needs the special strategy to follow. So they will be guiding you to have the proper strategy and proper roadmap to clear the GATE 2024 exam. All right. So let us start with the question number 1 from the fluid mechanics. Question number 1 on your screen. If the angle of contact of a drop of liquid is acute, which means less than 90 degrees, then what we can conclude from here? Options are on your screen. Adhesion is more than cohesion. These are intermolecular forces of attraction. Adhesion is between dissimilar molecules. Cohesion is between similar molecules. The option B says cohesion is more than adhesion. Option C says cohesion is equal to adhesion, and option D says adhesion and cohesion have no relation with the angle of contact. Yes, every one of you, please do let me know. Your time had already started to give the right answer. So when a water drop is, or when a liquid drop is placed on a surface, if the liquid spreads over the surface, If there is a spread of liquid on the surface, what does that mean? It means the angle, contact angle will be this angle, theta will be less than 90 degree. If the liquid is spread over the surface, it means the adhesion between the liquid and the surface is greater compared to the cohesion between liquid and liquid molecules. So we can say, cohesion is less than adhesion if theta is less than 90 degree. Yes, Parth, Kiran, Roshan, well done. Option A is the correct answer for this one. Let us move to question number 2. Let us move to question number 2. So whenever theta is less than 90 degree, the liquid is called as wetting liquid for the surface. When contact angle is greater than 90 degree obtuse, then cohesion is greater than adhesion and the liquid will be non-wetting liquid. That is the concept of surface tension and capillarity. The next question, again very simple question. It is all about the unit and dimension. Question number 2 on your screen. An oil of specific gravity 0.9 has viscosity of 0.28 stocks at 38 degrees Celsius. What will be its viscosity in Newton second per meter square? There are two types of viscosities. Options are already there on your screen. There are two types of viscosities. One is called as dynamic viscosity, whose unit is Newton second per meter square mu. Another is kinematic viscosity, or we can call it as momentum diffusivity. The unit is stock or meter square per second. And the relation between dynamic and kinematic viscosity is, the kinematic viscosity is dynamic viscosity per unit density of the fluid. Dynamic viscosity is independent of density of the fluid, but kinematic viscosity is inversely proportional to density of the fluid. So the question is to find out the dynamic viscosity in Newton second per meter square. So mu is equal to rho into kinematic viscosity, isn't it? So density of the fluid is 900 because specific gravity is given. Viscosity is 0.28 stocks into 10 to the power minus 4 meter square per second. One stock is equal to 10 to the power minus 4 meter square per second. So this will give you the answer in Pascal second or Newton second per meter square, or we can call it as kg per meter second. That is the dynamic viscosity, or we can also call it as coefficient of viscosity, or it can also be called as absolute viscosity because it is independent of density. Dynamic viscosity, absolute viscosity has nothing to do with the density. What is the answer? Yes, Kiran was the first to get the correct answer. Option C, Parth, Roshan. Well done, guys. What about others? I want every one of you keep responding, whether the question is easy or tough. Even if you are able to solve it, or even if you are not able to solve it correctly, still you should respond. So that will check where are you committing mistake, and that will help you to improve your understanding. All right, so that is how the practice always works in the betterment of your fundamentals, in improvement of your concepts. So please do like this session so it reaches to all your friends who are going to appear for this wonderful opportunity for mechanical engineers, that is BARC 2023. Let us move to question number 3. Question number 3. The question is from the manometer. The manometer shown in figure connects two pipes carrying oil and water respectively. It implies, the options are, pressure in both pipes are equal, pressure in oil pipe is higher, there are two pipes, one carrying oil and another carrying water. Pressure in water pipe is higher, insufficient data. The figure is also on the right hand side of the screen. Captain Ajay, the class is on YouTube. This is running on BYJU'S exam prep YouTube channel for civil and mechanical engineers. If you are part of my Telegram group, I have sent the link to join this class. Right? So your time starts now. Every one of you, please get me your answer. Simple, the question looks very simple, but yes, it is conceptual. The manometric fluid is mercury, which is having zero deflection in both the limbs of YouTube manometer. This is the horizontal plane given. Horizontal plane is given. And this is another horizontal plane given. Kiran. Oil pipe and water pipe are in the same horizontal plane, as well as the mercury level is also in both the limbs also in same horizontal plane. Yes, every one of you, please get me the answer. Which is having more pressure or data is insufficient? Beautiful question. Though it is conceptual, fundamental question, basic question. A, B, C. I am getting all options other than D. Anybody here for D? बताइए. Manometry की problem क्या है? The question look very simple. We develop the confidence, we develop the overconfidence to attempt the question from the manometry. But yes, if your concept basics are not clear, then you might end up getting the incorrect answer. Let us try to write the pressure equation. Let us write the pressure equation using the Pascal law and hydrostatic law. Let me call the pressure in oil pipeline to be PO. Let me call the pressure in water pipeline is PW. So if we write the pressure equation starting from PO, this is the datum line. I am using the datum line method. So PO, this point will also be having pressure PO. We are moving in downward direction plus density of oil we are traveling in into G. Let me assume this height as capital H. Let me assume this height as capital H. This is Px, the pressure at X, this is point X, is equal to, start from water pipeline, pressure in water pipeline is Pw. We are traveling in downward direction, so pressure increases with depth. Now we are traveling in water pipeline into G into H. This is Py. Px is equal to Py, isn't it? So we can write Po minus Pw is equal to PO minus PW is equal to rho W minus rho of oil into G into H, isn't it? And because the density of oil is less than density of water. Water is heavier fluid, having more density. Oil is lighter fluid. That is why oil always floats over water. You must be knowing that. So density of water is greater than density of oil. So can we say that is greater than 0? RHS is greater than 0. What does that mean? That means PO is greater than PW. Oil pipe will have more pressure than water pipe. What is the answer then? Oil pipe will have more pressure. Pressure in oil pipe will be higher than the pressure in water pipe. Is this clear? So Captain Ajay had given the right answer. I don't see any other student getting me the correct answer. Right? Shall we proceed further to question number 4? Question number 4. Read the question. If velocity potential function, what is velocity potential function? Phi, exists only for theoretical question from the kinematics. It exists only for the flow, steady flow. It exists only for the uniform flow. It exists only for the irrotational flow, or it exists only for the compressible flow. Yes, every one of you, please get me your answer. चलता रहूंगा पथ पर, चलने में माहिर बन जाऊंगा. चलता रहूंगा पथ पर, चलने में माहिर बन जाऊंगा. या तो मंजिल मिल जाएगी या फिर अच्छा मुसाफिर बन जाऊंगा. So you should keep on doing the right thing in the right direction. Success will definitely be yours. Question number 4. What is the answer? Velocity potential function exists only for irrotational flows. The velocity potential function only exists for irrotational flow, and that is why the potential flow is also known as ideal flow. What is potential flow? The potential flow is the flow for which the potential function exists, and it is also known as ideal flow. And what about the stream function? If we talk about the stream function, there are two functions. Stream function exists only for two-dimensional flows. It is valid for irrotational as well as rotational, but the flow must be 2D. For three-dimensional flow, stream function does not exist. That is the limitation of stream function. And similarly, the velocity potential function does not exist for rotational or real flows. All right. So combination of velocity potential function and the stream function is defined for two-dimensional irrotational flow problems in our fluid mechanics. All right. Let us move to the next one. Question number 5 on your screen. Numerical from the internal flow, laminar flow in a pipe. Formula based. Laminar developed flow. That means fully developed flow at an average velocity of 5 meters per second occurs in a pipe of 10 centimeter radius. The velocity at 5 centimeter radius is. The options are 7.5, 10, 2.5 or 5 meter per second. Read the question carefully, apply the concept correctly, do the calculation in the right manner and get me your answer. Yes, practice is what is important in getting your fundamentals correct or getting your concepts clear. So the more you practice, the more improvement in your fundamentals you develop. So always keep on practicing. It is not about revising the theory again and again. Keep practicing and keep checking your analysis. Keep doing the check. How many questions you have correctly attempted? How many questions you have wrongly attempted? So accordingly, you can improve or you can focus on those areas where you are having difficulty in getting the answers right. What is the answer? For laminar flow in a pipe, it is flow in a pipe. The velocity profile is given by U is equal to U maximum 1 minus small r square by capital R square. That is our velocity profile. That is parabolic. And U maximum is equal to twice of V average when the fully developed laminar flow takes place. When the flow is laminar, when the Reynolds number is less than 2000, isn't it? So the velocity at what is maximum velocity? If the average velocity is what is the average velocity? Average velocity is 5 meters per second. So maximum velocity is 2 into 5. So we can say at r is equal to 5 centimeter radius, u will be equal to 2 into 5, that is 10, multiplied by 1 minus small r, that is 5 centimeter, by capital R. Capital R is 10 centimeter. Take the square and then this will give you the answer. What is that? 10 into 1 minus 5 by 10 square. So 1 minus 1 by 4. So 10 into 3 by 4. 7.5 meter per second will be the correct answer. Option A. Kiran, it is option A which is the right answer, isn't it? Getting it? Anybody is having any doubt, you can just let me know through the comment section. I am more than happy to assist with your confusions. All right. So after this session, please go through the description box. There are important links which will help you in having your preparation better and better. There are free ebooks also available. You can follow the link in the description box, and do not forget to subscribe our BYJU'S exam prep YouTube channel so that you will be getting the important notifications from time to time for the various sessions we are bringing for your benefit. Let us move to question number 6. Question number 6 on your screen. The pressure drop in a 30 centimeter diameter horizontal pipe is 60 kilopascal in a distance of 15 meter. The wall shear stress in kilopascal is. Options are 0.1, 0.2, the unit has to be in kilopascal, 0.3 or 0.4. Yes, all of you. Yes, पार्थ, जब ये आप अचीव कर लेंगे कि रिवीजन करना बोरिंग लगने लग जाए, आपका इच्छा हो प्रैक्टिस करने की, इट मींस यू आर डूइंग द राइट थिंग इन द राइट डायरेक्शन. बिकॉज मोस्ट ऑफ द स्टूडेंट्स व्हाट दे बिलीव, बिकॉज द रिवीजन गिव्स द कॉन्फिडेंस कि मैंने प्रिपरेशन की है. इफ यू डू नॉट डू द रिवीजन, यू स्टार्ट फीलिंग fear in the back of the mind कि मैंने रिवीजन नहीं किया, what if I forget the formula, what if I forget the concept. तो ये वाली प्रॉब्लम आने लग जाती है. तो people keep on revising. But if you will practice some numericals from a particular topic, then that fear will definitely vanish. वो फियर आपका गायब हो जाएगा एंड यू विल एक्चुअली स्टार्ट डेवलपिंग द कॉन्फिडेंस इन द पर्टिकुलर टॉपिक। जब क्वेश्चन सॉल्व होने लग जाएंगे आपसे तो आपका फॉर्मूला की वजह से कोई क्वेश्चन नहीं गलत होगा। दैट इज माय प्रॉमिस टू एवरीवन। सो व्हाट इज द आंसर टू दिस वन? क्वेश्चन नंबर 6. Yes. So you must know that the expression for shear stress is given by minus dP by dx into R by 2. This expression is valid for laminar as well as turbulent. This is valid for laminar as well as turbulent because it is obtained by the Newton's second law or momentum conservation in the fluid flow. So the question is about the wall shear stress. So tau naught is equal to, because pressure is a function of x, that is linear. Pressure varies in the flow direction linearly. So we can write it as the pressure drop divided by length minus dP by dx is delta P by L into capital R by 2, or we can write it as d by 4. It can also be written as d by 4. So tau naught is to be asked, what is the pressure drop? 60 kilopascal. The answer is to be in kilopascal, divided by length, distance of 15 meter into the diameter is 30 centimeter, 0.3 by 4. That will give you the answer in kilopascal because 60 is in kilopascal. This is in meter. This is also in meter. Take care of the unit, meter getting cancelled out, and you will get it. So 15 into 4 is 60, 60 getting cancelled out, 0.3 kilopascal. Option C is the right answer. Option C. C is the right answer, isn't it? Yes, Kiran, Roshan, Captain Ajay, well done guys, well done, keep it up. Question number 7. Let us move to question number 7 quickly. The question is from the external flow or the boundary layer theory. The thickness of a laminar boundary layer on a thin plate is 2 centimeter at the half of the plate length. X is equal to L by 2. What is the thickness of boundary layer at the trailing edge of the plate? That is at X is equal to L. Options are 4.71, 4.414, 1.414, and option D is 2.828. Yes. Solve this one. Question number 7. बताइए. So whenever there is a fluid flowing over a flat plate, this is the flat plate, the boundary layer developed will be having an increasing nature. The boundary layer keeps on growing from the leading edge to the trailing edge. This is x is equal to 1, this is x is equal to 0 is the leading edge of the plate. This is the trailing edge of the plate. This is the direction of the flow. At x is equal to L by 2. Boundary layer thickness is 2 centimeter. What is the thickness of boundary layer at x is equal to L? So because it is the laminar boundary layer, when the Reynolds number is less than 5 into 10 to the power 5, the boundary layer will be laminar. So for laminar boundary layer, delta is directly proportional to root x. The growth of boundary layer in laminar flow or laminar boundary layer is such that delta is directly proportional to root x. For turbulent, delta is proportional to x to the power 4 by 5, isn't it? But because it is laminar, so root x. So delta 2 upon delta 1 is equal to under root of x2, that is L upon L by 2. So it will be root 2. So delta 2 will be root 2 times of delta 1. So 2 root 2 will be the answer. 2 root 2 centimeter will be the answer. Root 2 is 1.414 multiplied by 2, 2.828. Option D will be the answer. Question number 7. Yes. Ajay, Kiran, Roshan, Parth. These are the only students who are replying and replying correctly. I want others also, those who are here. I want every one of you to give me the answer for the questions on the screen. These practice questions are only for your benefits. The more you take advantage of these questions, the more fruitful the session will be. The question is, if the velocity potential function is given by x into y, the unit of velocity potential function is meter square per second, same as the kinematic viscosity. The resultant velocity at a point 1, in meter per second is 1, Options are root 2, pi by root 2, 2 and pi. What is the answer for question number 8? What will be the answer for question number 8? Yes, very nice, very simple. U is equal to minus of del phi by del x, right? Isn't it? In the direction of the flow, velocity potential function always decreases. In the flow direction, velocity potential function decreases, or flow takes place in the direction of decreasing potential. So if we take minus of del phi by del x, then you will get, isn't it minus y? U is equal to minus of del phi by del x, isn't it? It is the velocity potential function. Question number 8 now. So it will be minus y, and x is equal to 1 and y is equal to 1. So it will be minus 1. V is equal to minus of del phi by del y. That is minus x. So that is also minus 1. So the magnitude of resultant velocity is u square plus v square. That is under root of minus 1 square plus minus 1 square. That will be root 2 or 1.41 for option A. A will be the answer. Right? Option A. Question number 8, option A will be the answer. Let's move to question number 9. Question number 9 on your screen. The question is from the hydrostatic forces. An inclined plate. It is a plane surface, but it is kept inclined 2 meter long and 1 meter wide, lies with its length inclined at 45 degree to the surface of water, and its nearest edge is 1 meter below the free surface of water. Then the total pressure force on the plate in kg is approximately. Options are 2150, 2510, 3220 and 3420. The unit should be taken care. The unit should be taken care. Can you solve it? Yes. This is, let us say, free surface of the liquid. The plate is 2 meter by 1 meter and it is 1 meter. So the plate is something like this. This is the plate, this is 2 meter, this is 1 meter. And this top edge of the plate is 1 meter below the free surface. This is also 1 meter. So if the angle made by this is 45 degree, this angle is 45 degree. What is the answer? Can you solve it? This is the centroid G. So we need to find out X bar, because the formula says the force will be acting like this. This is acting at Cp. So the force, hydrostatic force, is rho of fluid into G into A into X bar. So rho fluid is, the answer to be in kg, actually kgf. 1 kgf, the unit of force. Force can be having the unit as kgf. 1 kgf is equal to G Newton. So you should convert Newton into kgf. G Newton is equal to 1 kgf. So we can write it as 1000 into G into area 2 into 1. What is X bar? X bar, if you are able to find out correctly, this is 1 plus this will also be 1, but this will be 1 sine 45, isn't it? 1 into sine 45. What is sine 45? Is it sine 45 or cos 45? Will it be sine 45 or cos 45? So X bar will be equal to 1 plus 1 by root 2. And what is 1 by root 2? 1 by root 2 is 0.707, isn't it? What is 1 by root 2? Isn't it 0.707? So X bar will be equal to 1 plus 0.707. That will be in kgf. That will be Newton, sorry. That will be Newton. That will be in Newton. So convert it into kgf. G Newton is equal to 1 kgf. So it will be 2000 into 1.707 kgf. That will be the answer. 2000 into 1.707 kgf. So it will be around 3414.2 kgf. It is not kilogram actually. So sometimes to confuse you, they ask the answer in kg. So 3420. The nearest option is question number 9. The nearest option is option D. D will be treated correct. Question number 9. Right? Any doubt? So it is all about X bar. If you are able to find out the X bar, you can also find out the depth of CP, HCP. You can also find out the depth of CP. What is HCP? HCP is equal to X bar plus IG by AX bar. Sine square 45. You can find out the depth of CP from the free surface using the formula. Right? But the question is not about the depth of CP. Let us move to question number 10. Question number 10 is from the Pascal law. Very, very simple question. A hydraulic press, ram of 15 centimeter diameter and a plunger of 1 centimeter diameter. It is required to lift a mass of 1000 kg. The force required on the plunger is nearly equal to. Options are 100 Newton, 1000 Newton, 10,000 Newton, or only 10 Newton. Very, very simple question. I want every one of you to get me the correct answer for question number 10, and your time starts now. All of you waiting for your response. Let me see who will be the first and who will give me the right answer to this simple yet conceptual question. बताइए. Yes. If you do not practice, if you do not involve in the question practice, you do not deserve to win. So someone will get better. If you are not practicing, then your competitor will become better than you. And it is the relative competition which is going to matter in clearing any competitive examination. So do not leave a single stone unturned to crack this examination, which is very wonderful, beautiful opportunity for you to get into BARC 2023. चैंपियन जरूर हिंदी में बोलेंगे. आप उसका आंसर बताइए. इस क्वेश्चन का आंसर सॉल्व करके बताइए. पहले क्या आंसर होगा? आप देखेंगे कि ऑल द ऑप्शंस आर हैविंग ए डिफरेंस ऑफ 1-0. जरा सी गलती, जरा सी भूल, यू विल गेट द इनकरेक्ट आंसर. इसलिए मैंने ये क्वेश्चन आपको दिया है. बताइए. इसलिए मैं आपसे चाहता हूं कि आप लोग इस क्वेश्चन का मुझे जवाब दीजिए. A hydraulic press has a ram of 15 centimeter diameter. ये ऐसा होता है hydraulic press. This is the ram. And this is the plunger. Piston. हम अप्लाई करते हैं F1 to the plunger. Area of plunger is A1. And we get F2, increase force because of Pascal law. So according to Pascal law, pressure remains constant in a horizontal plane. यहाँ का pressure P1 is equal to यहाँ का pressure 2. This is 0.1, this is 0.2. Hydraulic press, hydraulic ram, hydraulic jack, hydraulic ये सब सारे के सारे पास्कल लॉ पे वर्क करते हैं. Pascal's law. What is P1? F1 by A1 is equal to normal force per unit area. So हमें क्या चाहिए? The force required on the plunger. F1 की वैल्यू चाहिए. F1 is equal to F2 multiplied by A1 by A2. A1 को लिख सकते हैं pi by 4 D1 square. A2 को लिख सकते हैं pi by 4 D2 square. Because circular cross section. Pi by 4 getting cancelled out. So F1 is equal to F2 multiplied by D1 by D2 whole square. F1 is equal to F2. F2 कितना है? F2 होगा 1000. मास है टू लिफ्ट ए मास ऑफ 1000 kg. वेट हो जाएगा 1000 इंटू 10 9.81 m इंटू जी. दिस इज m ओनली. m इंटू जी 1000 इंटू 10 मल्टीप्लाइड बाई d1 बाई d2. व्हाट इज d1? 1.5 डिवाइड बाई d2 15. दोनों सेंटीमीटर है स्क्वायर. तो ये हो जाएगा 1000 इंटू 10 डिवाइड बाई 100, 1000 into 10 डिवाइड बाई 100, स्क्वायर है यहाँ पे, इट इज स्क्वायर हियर, समझ में आ रहा है आप लोगों को? सो 1000 into 10 डिवाइड बाई 100, क्यों मैंने 100 लिखा? बिकॉज 15 by 150 that is 1 by 10 square. So 100 से अगर कैंसिल आउट करेंगे 10 and 10, so it is 100 Newton. ऑप्शन ए, A will be the correct answer, not C. C गलत है, A will be the right answer for this one. 100 Newton will be the right answer, isn't it? बताइए कोई कंफ्यूजन? रोशन, चैंपियन, पार्थ, किसी ने भी सही जवाब नहीं दिया? Nobody has responded with the right answer. Let us move to question number 11. There are 10 more questions to go. Question number 11 on your screen. Beautiful question, simple. A metal ball weighs 9 kilonewton in air, but the weight is 7.5 kilonewton in a fluid of specific gravity 0.75. क्यों कम है weight? Because the buoyant force opposes the weight. So the apparent weight will be less. 7.5 kilonewton will be the apparent weight. Then what is the specific gravity or relative density of the ball material? Options are 6, 5, 4.5 and 3.5. Every one of you. The question is from buoyancy and flotation. Apparent weight. The question is about the apparent weight. Get me the answer. Question number 11. Give it a try. Nine kilonewton in air. Density of air is very small density than the density of liquids. So the density of air is very small. Buoyant force by air can be ignored. Very small. Buoyant force by air is very small. So the weight in air is the actual weight. We can call it as actual weight. But here it is the apparent weight. Apparent weight. So if we, what is the answer? Solve कर रहे हैं आप 6, 5, 4.5 और 3.5. Give it a try, every one of you. Otherwise, allow me to solve this question. The actual weight is equal to rho of the ball into total volume of the ball into G is equal to 9 kilonewton. That is equation number 1. The second equation says the weight is 9 kilonewton, but there is a buoyant force by the fluid. So the apparent weight 9 minus buoyant force by the fluid is equal to 7.5 kilonewton, isn't it? That is 7.5 kilonewton. So the buoyant force by the fluid is equal to 9 minus 7.5, isn't it? So the buoyant force by the unknown fluid, which is density of unknown fluid into volume of the ball, because it is completely submerged into G, is equal to 9 minus 7.5. That is equal to 1.5 kilonewton. The buoyant force is 1.5 kilonewton. This is equation number 1. This is equation number 2. If you divide these two equations, then you will get VB getting cancelled out, GG getting cancelled out. So density of the ball is equal to 9 upon 1.5 into density of the fluid, right? If you divide the whole expression by density of water, this will be specific gravity of the ball is equal to 9 upon 1.5 into this will be specific gravity of the unknown fluid. And what is the specific gravity of unknown fluid? That is 0.75. What is the answer? 6 into 0.75. 6 into 0.75. 4.5 is the specific gravity of the unknown fluid. 4.5. The answer will be 4.5. C is the correct answer. 4.5. Is this clear? Yes, free fire. Well done. Keep it up. Good, good. Captain Ajay, Parth. Very nice. 11. Question number option is C. Very nice. Let us move to question number 12. This is the last question from the fluid mechanics. Then some question will be there. 8 question will be there from the heat transfer. Assume that the viscosity of water is 1 centi stop. Which viscosity is it? Kinematic viscosity. at room temperature, then the maximum permissible pipe diameter for maintaining the laminar flow in a pipe with a velocity of 1 meter per second is. You need to find out the maximum diameter for which the flow in the pipe is still laminar. Options are 12.5 mm, 6.75 mm, 4 mm, or 2 mm. These are the options. These are the options. Can you solve it? Question number 12, the last one from the fluid mechanics. Then there will be questions from the heat transfer. A knowledge of is no value unless you put it into practice. किसी ने बोला भी है, when I hear, I forget. When I see, I remember. When I do, I understand. So doing it will give you the proper understanding of the fundamentals. What is the answer to question number 12? Yes, 2 mm. For Reynolds number to be maximum, that is 2000 for laminar flow. The condition is to maintain the laminar flow. Internal flow 2000 is equal to V average into D maximum upon kinematic viscosity. Question is to find out D maximum. What is the maximum diameter for maintaining the laminar? 2000 into kinematic viscosity. Centistoke 1 into 10 to the power minus 2 stock into 10 to the power minus 4 meter square per second. Divide by average velocity. 1 meter per second is the average velocity. If nothing is mentioned about the velocity, it is always average velocity. So it will be 2 into 10 to the power minus 3 meter. The maximum diameter is in meter, and in millimeter it will be 2 mm. Option D. D is the right answer. हाँ, एक्चुअली ये 1 मीटर पर सेकंड कोई मैक्सिमम वेलोसिटी ले ले तो कंफ्यूजन हो सकता है. व्हेन नथिंग इज मेंशन, कुछ भी नहीं बोला जाए, तो इट इज ऑलवेज अज्यूम टू बी द एवरेज वेलोसिटी ऑफ फ्लो. लेट अस मूव टू क्वेश्चन नंबर 3. क्वेश्चन का डायग्राम पहले आ गया, क्वेश्चन अब आया है. ब्यूटीफुल क्वेश्चन, थोड़ा सा लेंथी हो सकता है, बट यस, there is a circular ice sink. It is a circular in shape, 25 meter in diameter, is enclosed by a hemispherical dome 35 meter in diameter. If the ice and the dome surface may be approximated as the black bodies and are at 0 degrees Celsius, this is at 0 degrees Celsius, dome is at 15 degrees Celsius. What is the net rate of radiation heat transfer from the dome to the sink? Dome is 2, sink is 1. So Q2 to 1 net is how much? Options are 5 into 10 to the power 5, 3.69 into 10 to the power 4, 1.4 into 10 to the power 4, and option D says 6.25 into 10 to the power 4. Let me see who will get me the right answer for this one. दोनों black है. Epsilon 1 is equal to epsilon 2 is equal to 1. Both are taken as the black bodies. Yes. Let me see who will be able to solve it. Question number 13. First question from the heat transfer, and in the series order it is question number 13. बताइए. कर सकते हैं. दो तरीके हैं. इन दोनों के बीच में थर्मल रेजिस्टेंस कौन सा होगा? Only space resistance. There will be only space resistance because both are black bodies. Surface resistance 0 होगा. Surface resistance will not be there. Both are black bodies. So can we say Q2 to 1 net is equal to sigma T2 to the power 4 minus T1 to the power 4 divided by the space resistance 1 upon, either we write F122 or 1 upon A2 F221. वो आपकी मर्जी है, बिकॉज A1 F122 इज इक्वल टू A2 F221. F221 फाइंड आउट करना कंपैरेटिवली डिफिकल्ट होगा. F122 फाइंड आउट अगर कर लेते हैं, if we are able to find out F122, look, because it can be treated as an enclosure, so enclosure theorem, F11 plus F122 is equal to 1, right? I sink is a flat surface, self shape factor for a flat surface is 0. So F122 is equal to 1. तो Q221 नेट की वैल्यू लिखी जा सकती है सिग्मा इंटू A1 इंटू T2 to the power 4 minus T1 to the power 4. Do you guys agree or not? Do you guys agree or not? एग्री करते हैं? जरूर करते होंगे, कोई ऑप्शन नहीं है. तो सिग्मा इज 5.67 इंटू 10 टू द पावर माइनस 8. A1 कितना है? पाई बाय 4 इंटू D1 स्क्वायर. व्हाट इज D1? D1 इज 25 मीटर, 25 स्क्वायर इंटू इसका टेम्परेचर है 15 डिग्री सेल्सियस, इसका टेम्परेचर है 0 डिग्री सेल्सियस. You should write the temperature in Kelvin. 15 plus 273, 288 to the power 4 minus 0 degree, 273 to the power 4. If you will do the calculation, then Q221 net आपको मिल जाएगा. Q221 net की वैल्यू मिल जाएगी. What is that? बताइए. Are you guys getting 3.69 into 10 to the power 4 watt or not? 3.69. Isn't it 3.69 into 10 to the power 4? हाँ पार्थ, एक्चुअली जो प्रॉब्लम आप बता रहे हैं ये सारे के सारे लोगों के साथ है. बहुत लोगों से ये सब गलतियां होती है, और जहां पे आपने गलतियों को कंट्रोल कर लिया, जितना आपने गलतियों को कम किया एग्जामिनेशन में, जितना आपने टाइम को अच्छे से यूटिलाइज किया, टाइम मैनेजमेंट आपने सही किया, क्वेश्चन सिलेक्शन सही किया, नॉलेज, इट इज नॉट ओनली द नॉलेज की जिसको ज्यादा नॉलेज है वो ज्यादा अच्छा मार्क्स लेके आएगा. इट इज ऑल अबाउट दैट मैनेजमेंट ऑफ टाइम. इट इज ऑल अबाउट द मैनेजमेंट ऑफ प्रेशर, हैंडलिंग द प्रेशर, बूस्टिंग अप योर कॉन्फिडेंस, डीमोटिवेशन तो नहीं आ गया, सिलेक्शन ऑफ द क्वेश्चन और एक्यूरेसी, ये सब चीजें. तो जितना आपने अपने इसको एनालिसिस को सिंपल रखा, अपनी स्ट्रेटेजी को जितना सिंपल रखा और गलतियां कम से कम की, तो डेफिनेटली यू विल बी अहेड ऑफ योर कॉम्पिटिटर्स. 3.69 into 10 to the power 4 watt. B is the correct answer. The nearest option is 3.68. The nearest answer is option number B. B is the right answer, isn't it? आप चाहें तो F221 से भी कर सकते थे. F221 कैसे निकालते? देखिए यहाँ पे F122 की वैल्यू 1 होगी. F221 फाइंड आउट करने के लिए रेसिप्रोकेटी थ्योरम थोड़ा सा कॉम्प्लिकेट हो जाता, बट यहाँ पे आपको लिखना पड़ता सिग्मा इंटू A2 इंटू F221 इंटू T2 टू द पावर 4 माइनस T1 टू द पावर 4, और F221 को फिर से आप A1 F122 अपॉन A2 लिखते तो A2 गेटिंग कैंसल आउट, वही सब मिल जाता. सो इट डज नॉट मैटर वेदर यू आर कैलकुलेटिंग F122 और F221, सेम ही आएगा. क्योंकि अगर आपने F221 को A1 F122 अपॉन A2 लिख दिया तो A2 से A2 कैंसिल आउट हो जाएगा, सेम ही आएगा. क्वेश्चन नंबर 14 पे चलें. बहुत अच्छा ऑब्जर्वेशन है, फ्री फायर. क्वेश्चन नंबर 14 सिंपल है, बट कई बार क्वेश्चन थोड़ा लेंथी मिल सकता है, तो आपको ये फीलिंग आ सकती है कि क्वेश्चन अगर लेंथी है तो सॉल्यूशन भी लेंथी होगा. क्वेश्चन पढ़िए, ठंडे दिमाग से पढ़िए, समझिए, और फिर जो कॉन्सेप्ट है वो इंप्लीमेंट करिए. There is a wire of 1.5 millimeter diameter and 200 millimeter length is submerged in water to boil the water at 100 degrees Celsius. How much electrical power must be supplied to the wire to maintain it at 130 degrees Celsius if the heat transfer coefficient is given by this? Simple है. Options are 92.6, 46.3, 24.2 and option D says 125 watt. Let us start the timer. Question number 14. Yes, all of you, those who have joined me late, it is my humble request to all of you, please do not forget to like this session and do subscribe this BYJU'S YouTube channel so that you will get the notification, and don't forget to press the bell icon. कर सकते हैं, सिंपल है. इलेक्ट्रिकल पावर आ गया, इससे क्वेश्चन कॉम्प्लिकेट नहीं होगा. द इलेक्ट्रिकल पावर रिक्वायर्ड, इलेक्ट्रिकल पावर इज नथिंग बट एनर्जी पर यूनिट टाइम. So the electrical power, electrical energy per unit time required is same as the heat energy lost per unit time. So we need to find out the loss of heat energy that is due to convection, H into surface area into delta T, because the mode of heat transfer through the wire is convection, and the length diameter is very, very small compared to the length. So the loss of heat will be only from the periphery of the wire. So H is 3275, area is pi into diameter. Diameter is 1.5 mm, 1.5 into 10 to the power minus 3 into length, that is 0.2 meter, and delta T is 130 minus 100. Do the calculation, you will get the answer in what? कितना आ रहा है ना? 125 तो नहीं आएगा कैप्टन अजय. 3275 into pi dl, मैंने ये सरफेस एरिया पाई dl लिखा है क्योंकि वायर का डायमीटर बहुत कम है, लेंथ से साइड एरिया इज इग्नोर्ड. D will not be the answer. कैलकुलेशन करिए, पाई dl into 130 minus 100, बल्क टेम्परेचर डिफरेंस मेरे हिसाब से 92.6 आना चाहिए. चेक करिए और बताइए. दैट इज द इलेक्ट्रिकल पावर रिक्वायर्ड. क्वेश्चन और भी कॉम्प्लिकेट हो जाता अगर हीटर की और जहां से इलेक्ट्रिकल पावर दे रहे हैं उसमें भी कुछ एनर्जी लॉस हो रहा था, उसकी भी एफिशिएंसी गिवन होती. अगर उसकी भी एफिशिएंसी गिवन होती. बी भी नहीं आ रहा है. क्या कहां गलती कर रहे हैं आप लोग? व्हाट इज द मिस्टेक यू गाइस आर कमिटिंग? बताइए जरा मुझे. 3275 into pi into D 0.0015 into L 0.2 into 130 minus 100, that is 30. 92.59 92.6 option A. Question number 14 option A. Question number 15 on the screen. Quickly solve करिए. Question number 15. The temperature profile for flow over a flat plate is given by this expression. This is the temperature profile. This is Ts sin pi y by 0. If the thermal conductivity of the fluid, the value of the convective heat transfer coefficient H is. Beautiful question. Simple है but beautiful है. कैसे? क्योंकि in the no slip condition, in case of no slip condition, the mode of heat transfer is conduction. So Q can be written as minus thermal conductivity of the fluid into area available for conduction into temperature gradient in the no slip region is equal to H into area available for convection into delta T, bulk temperature difference. So from here we can find out the value of H. So H can be written as, can you let me know the answer? Question number 15. क्वेश्चन नंबर 15 का आंसर बताइए. क्वेश्चन नंबर 15 सिंपल है. H is equal to minus kf into dt by dy at y is equal to 0 upon delta t. delta t ये रहा, ts minus t infinity is delta t. इसको अगर मैं dt by dy at y is equal to 0 कैलकुलेट करूं तो that will be delta t into sin का डिफरेंशिएशन cos of y की वैल्यू 0 पुट करनी है 0 into pi upon 0.015 into pi upon 0.015 ये dt by dy. So it will be thermal conductivity is negative आएगा यहाँ पे. It will be negative. dt by dy will be negative. So thermal conductivity will be 0.03. 0.03 cos 0 is 1 pi upon 0.015 upon delta t. यही तो होगा. डेल्टा टी तो हो गया. डेल्टा टी से डेल्टा टी कैंसिल आउट हो जाएगा. यहाँ पे भी डेल्टा टी आएगा, यहाँ पे भी डेल्टा टी आएगा. दैट विल गेट कैंसिल. सो इट विल बी 2 पाई. द आंसर H will be 2 pi. So 2 into 3.14 6.28 watt per meter square Kelvin, isn't it? 6.28. B. Question number 15 option B is the right answer. Right? Let us move to question number 16. Question number 16 very simple. ये थोड़ा straight line है. It is a straight line. It is a curve like this. It is a curve like this. or it is a parabola like this. The thermal conductivity of a plane wall varies with this variation. K is equal to K naught 1 plus beta T. Which of the following is the temperature profile if beta is greater than 0? Question number 16. अगर K की वैल्यू कांस्टेंट होती तो टेम्परेचर प्रोफाइल लीनियर होता, और अगर हीट जनरेशन होता, Q जनरेशन नॉन जीरो होता तो टेम्परेचर प्रोफाइल पैराबोलिक होता, ये लीनियर होता। और अगर K इज इक्वल टू K नॉट 1 माइनस बीटा अगर लेस देन 0 होता, बीटा की वैल्यू अगर नेगेटिव होती तो ये कर्व होता बीटा ग्रेटर देन 0 के लिए। ऑप्शन बी इज द करेक्ट आंसर। बी इज द राइट आंसर। ऑप्शन बी फॉर क्वेश्चन नंबर 16, isn't it? ऑप्शन बी, क्योंकि हम बोल सकते हैं Q इज कांस्टेंट, Q इज कांस्टेंट, Q is equal to minus Ka into dt by dx is constant. So we can say dt by dx is inversely proportional to K. जैसे जैसे थर्मल कंडक्टिविटी, जैसे जैसे x बढ़ रहा है टेम्परेचर डिक्रीज करेगा, क्योंकि हीट फ्लो का जो डायरेक्शन है वो पॉजिटिव x डायरेक्शन है, डायरेक्शन ऑफ हीट फ्लो। सो टेम्परेचर डिक्रीज करेगा, और टेम्परेचर डिक्रीज करेगा तो K भी डिक्रीज करेगा, और अगर K डिक्रीज करेगा तो dt by dx will increase. So increasing dt by dx curve is this. Option B. B is the correct answer. Question number 17. Simple. Memory based question. Question number 17. What is the answer? Simple है question number 17. क्या कहां कंफ्यूजन है? फ्री फायर क्या कंफ्यूजन है? टेम्परेचर यहां पे ज्यादा है, यहां पे कम है। हर में टेम्परेचर ए बी सी की अगर हम बात करते हैं, x इज इक्वल टू 0 पे टेम्परेचर ज्यादा है, x इज इक्वल टू l पे टेम्परेचर कम है, तो डायरेक्शन ऑफ हीट फ्लो विल बी इन पॉजिटिव। तो यहां पे dt बाई dx इंक्रीज कर रहा है, यहां पे स्लोप इंक्रीज कर रहा है, और यहां पे स्लोप डिक्रीज कर रहा है, यहां पे स्लोप कांस्टेंट है। तो जैसे जैसे x बढ़ा रहे हैं टेम्परेचर डिक्रीज कर रहा है, k भी डिक्रीज करेगा, तो dt बाई dx स्लोप इंक्रीजिंग होना चाहिए फ्रॉम x इक्वल टू 0 टू d। तो तब होगा जब हीट जनरेशन है, ये है मैक्सिमम टेम्परेचर। D option will be correct when there is a heat generation. When there is a heat generation, then the heat will flow in both the sides from the maximum temperature. नहीं फ्री फायर, मेरे को आपका क्वेश्चन नहीं समझ में आया। स्लोप की बात हो रही है, ग्राफ तो सारे में टेम्परेचर तो तीनों में ही डिक्रीज कर रहा है। x इज इक्वल टू 0 से x इज इक्वल टू l, टेम्परेचर तो तीनों में डिक्रीज कर रहा है, बट स्लोप फर्स्ट में कांस्टेंट है, सेकंड में इंक्रीज कर रहा है। स्लोप मतलब टेंजेंट एंगल tan थीटा, थीटा की वैल्यू इंक्रीज कर रही है, और सी में स्लोप डिक्रीज कर रहा है। यहां पे है फ्लैट सरफेस, यहाँ पे स्टीप, जब फ्लैट से स्टीप की तरफ कर्व जाता है तो स्लोप इंक्रीज करता है। इधर ये स्टीप, स्टीप से फ्लैट की तरफ अगर कर्व मूव करता है तो इसका मतलब स्लोप डिक्रीज कर रहा है। सो सी में स्लोप डिक्रीज कर रहा है, बी में स्लोप इंक्रीज कर रहा है, बट क्योंकि बीटा की वैल्यू ग्रेटर देन 0 है तो स्लोप की वैल्यू इंक्रीज करनी चाहिए, राइट। अगला क्वेश्चन, क्वेश्चन नंबर 17, सिंपल है। रिनॉल्ड नंबर के साथ एक्सप्रेशन नसल नंबर का, नसल नंबर इज प्रोपोर्शनल टू रिनॉल्ड नंबर टू द पावर 1/2 इनटू प्रांटल नंबर टू द 1/3। ये लेमिनार के लिए होता है। नसल नंबर इज प्रोपोर्शनल टू रिनॉल्ड नंबर टू द पावर 4/5 इनटू प्रांटल नंबर टू द पावर 1/3, वो टर्बुलेंट के लिए होता है। ये रिलेशन होता है। तो रिनॉल्ड नंबर के साथ रिलेशन जो होगा 0.5 फॉर लेमिनार एंड 0.8 फॉर टर्बुलेंट। कोई है ही नहीं ऑप्शन, नन ऑफ दीज, नन ऑफ दीज, कोई भी ऑप्शन करेक्ट नहीं है। अगर फिर भी लगाना हो तो हम ये ऑप्शन टिक कर सकते हैं, ऑप्शन ए। दिस इज फॉर टर्बुलेंट एंड दिस इज फॉर लेमिनार। फॉर लेमिनार इट इज 0.5, फॉर टर्बुलेंट इट विल बी 0.8 रेस्पेक्टिवली लिखा हुआ है, तो पहले लेमिनार का आना चाहिए था। तो अगर फिर भी कई बार क्वेश्चन में हो सकता है प्रिंटिंग मिस्टेक, देयर इज ए कैलकुलेशन, देयर इज सम मिस्टेक इन द क्वेश्चन, still you need to select the answer, then option A will be more appropriate than any other options. All right. So option A can be treated correct for this one. The next question, question number 18. There are a couple of more questions to go. And day after tomorrow, I will be again coming for the Menti session for this BARC 2023 exam. Day after tomorrow, again there will be a session. For a composite wall shown in figure, figure kahan hai? This is the figure. There are 4 materials, 1, 2, 3, 4. What will be the correct circuit diagram? Electrical analogy नहीं, electrical circuit नहीं होना चाहिए था, thermal circuit होना चाहिए था. Electrical circuit तो बनेगा नहीं. It will be the thermal circuit. What is the answer? The only thing you need to check is the value of thermal resistance. The value of thermal resistance. For one, the area is, let us say, A. So it is L by Ka. Thermal resistance for conduction is L by Ka. So it will be La upon area into Ka. For second one, this is Kb. So Lb upon Kb into A by 2. Second one, it is Lb upon Kb into A by 2. It will be A by 2. And third one will be, third के लिए भी ऐसा ही कुछ होगा, Lb upon Kc into A by 2. बस ये ध्यान देना है. And fourth one will be equal to Lc upon Kd into area. So the correct answer will be option number 18 का जो right answer है, that will be option number B. B will be the answer. A by 2 होगा. Yes, Captain Ajay. Yes, Rashad. Well done. Question number 19 पे आ जाते हैं. Question number 19. Question number 19 on your screen. In which of the following situation the unsteady state heat conduction problem can be solved by using the lumped heat parameter analysis? Thermal conductivity is infinite, K is infinite, and H is finite. That is correct. To have the unsteady analysis, lump analysis, internal temperature gradient are infinite. No. dt by dx must be 0. Temperature gradient must be 0. 2 is not correct. Biot number is less than or equal to 0.01. That is also incorrect. Biot number should be less than equal to 0.1 only. Conductive resistance should be less than equal to 1/10 of convective resistance. 3 is also incorrect. Conductive thermal resistance should be very, very less than convective thermal resistance. 4 is correct. Temperature variation with respect to the thickness is negligible. Yes, dt by dx is equal to 0. Temperature is not a function of x. Temperature is a function of time only. So fifth is also correct. 145, 145, 145. Option B. 1, 4 and 5 are correct. Option B. B is the right answer for question number 19. And let us move to the last question for the day. I hope you guys have enjoyed the session. The question is from the heat exchanger. The question is from the heat exchanger. Get me the answer for this one. It is a condenser. In condenser, hot fluid is undergoing a phase change. The temperature profile will be a horizontal line, and the direction of flow, the relative direction of the fluid flow becomes insignificant as far as the performance is concerned. I hope you know about the condenser. The condensing steam at 70 degrees Celsius to have a capacity of 100 kilowatt. This is the heat transfer rate or the thermal capacity. Water 20 degrees Celsius is used and outlet temperature is limited to 45 degrees Celsius for water. Overall heat transfer coefficient is this. The surface area required will be, options are on your screen. Options are there on the screen. So please do like this session. So it will help. If you like the session, it will help you to reach the session to all the aspirants who are going to appear for BARC 2023 examination. All right. Question number 20. What is the answer? Every one of you. If I draw the temperature profile, this is steam. This is 70 degrees Celsius. This is also 70 degrees Celsius. Water is moving from 20 and 45. If we calculate delta TM, LMTD for this heat exchanger, that is 70 minus 20 minus 70 minus 45 upon natural log of 70 minus 20 upon 70 minus 45. What is LMTD? 50 minus 25. Delta TM 50 minus 25 upon natural log of 50 by 25. What is ln of 2? 25 upon ln of 2. What is ln of 2? Do you know? 0.6. What is ln of 2? 0.693. So it is 25 upon 0.693. That is delta T. And Q is equal to U into A into mean temperature difference. So U will be equal to Q, that is 100 kilowatt. So 100 into 10 to the power 3. It will be 100 into 10 to the power 3 upon area. What is the area? Area is actually to be calculated. U is 3100. It will be the area which is unknown. 3100 into what is delta TM? Delta TM is 36.06 meter square. That will give you the answer. Area will be this. Can you solve it? Can you find out the answer for question number 20? Are you getting 0.894 or not? Are you guys getting 0.894 or not? 0.894. Option A. Option A will be the correct answer for this one. So guys, that is all from my side. I hope you enjoyed the session and you have improved your fundamentals. You were able to apply those concepts in the numericals. The portion which is difficult for you to analyze, or the portion for which you were not able to get the right answer, please do revise, do practice more and more question, and you can always connect with me through the mail ID, and please do join me on the Telegram group as well. रशद, आपके लिए एक ही बात बोलना चाहूंगा कि अभी तो असली मंजिल पाना बाकी है, अभी तो इरादों का इम्तिहान बाकी है, अभी तो तोली है मुट्ठी भर जमीन, अभी तोलना आसमान बाकी है. सिर्फ एक एग्जाम आपका करियर नहीं डिसाइड कर सकता. देयर आर लॉट ऑफ एग्जाम्स, सो मेनी एग्जाम्स. Please keep your momentum high, keep your motivation high. Success will definitely be yours. Success can be delayed, but it cannot be denied. अगर आपने अपने आप को मोटिवेट रखा कि आपको करना है, ये जुनून सवार करिए, तो डेफिनेटली nobody can stop you. एक एग्जाम गलत हो सकता है, but it is always the learning from your mistake. अगर जो गलतियां हुई हैं वो आप अगले एग्जाम में ना रिपीट करें, तो डेफिनेटली देर ही सही बट आपका सिलेक्शन जरूर होगा रशद. डोंट वरी. ऑलराइट, नो प्रॉब्लम. जॉब के साथ कर सकते हैं क्योंकि थ्योरी आपने पढ़ ली है, क्लासेस आपने सारी अटेंड कर ली है, यू आर हैविंग एवरीथिंग, नोट्स आपके पास हैं, क्वेश्चन बैंक आपके पास हैं. जस्ट यू कंटिन्यू योर प्रिपरेशन. अपने आप को रोकना नहीं है, रुकना नहीं है. देन डेफिनेटली आज नहीं तो कल आपका दिन आएगा. Thank you. With this note, let me take your leave. Enjoy. Thank you for joining in. Thank you for your participation. And see you in the next session day after tomorrow. Till then, enjoy. Take care. Have a good day. Have a good night. See you. Take care and Jai Hind. Thank you guys. Thank you very much.